Hello, everybody, and thank you for coming along to my talk. Tonight, we are going to be talking about the lessons that we learned when building a serverless application. My name is Gerald Stewart. I'm a principal software engineer at Liberty IT, and I'm also an AWS Community Builder. So first of all, to start off, I'm going to talk about what did we build, and then I'm not going to talk about it for the rest of the night. So Liberty IT is an insurance company, and we are the IT arm of our parent organization, Liberty Mutual Insurance, which is a 111-year-old insurance company. We built a modern home insurance platform using the AWS CDK, AWS Lambda, DynamoDB, API Gateway, and we had a Fargate service as well. We released it to production in January 2022, and it has now been rolled out to multiple states across the United States. Yes, there's 5 Liberty IT engineers involved in the project and 5 Liberty Mutual engineers. Some which I actually have the pleasure of being here tonight. Visitors were over all week, so great to have you here. So I'm going to talk about a few things tonight. First of all, we're going to talk about how we use project design and standardization. We're going to talk about gateway design. We're going to talk about data management, and we're going to talk about performance. So to start it off, project design and standardization. What did we do? We built single purpose applications. These have smaller code bases, faster build pipelines, and less chance of developers blocking each other. Previously, we had legacy applications that had large code bases, large amount of endpoints, and really a large amount of traffic. And that might stop people getting stuff out to production because somebody else's change can't go. When we have small projects, that issue doesn't really arise. The chart on the right-hand side is actually my team's deploy frequency for the last 4 months of 2022. So we had 14 applications. On average, I think we deployed 29 times each month, which is like 1.4 times a day, which is pretty impressive stat. So coming from, obviously, when you consider like the applications that we integrate with as an 111-year-old company with a large digital presence. So another thing we kind of picked up on is separating our storage and compute. Even till today, you're still discovering projects that look like this. So this is one cloud formation stack or one project that has your compute, your storage, your gateway, all your key infrastructure in one place. The blast radius of something like this is insane. You really want to be splitting things out and kind of removing the risk. So how do we do this? We have a compute stack that would have our Lambda functions in it. We would have a gateway stack, which would contain like our API gateway. We would separate out each storage instance to its own project to isolate changes and reduce the amount of possible failures. And we would also split out an infrastructure stack. Now, that would serve purpose for reusing of key components like KMS keys. So KMS keys $1 a month for each key, but if you have 50 Lambda functions that your team owns, you don't need to create 50 KMS keys. You create one central KMS key and you reuse that across all of them. We thought this is the most effective way. It's worked really well for our team, and it's really like ease like the developer experience as well. So another thing we've been doing is driving consistency using the AWS CDK. So the AWS CDK Cloud Development Kit allows you to manage your infrastructure using object-oriented programming languages. We use TypeScript. At the start of our journey, we often find ourselves applying the same change to a large number of projects. So we might have to go through and add an environment variable or update a property on every single function that we owned. We thought that, and then we realized that we could create these CDK constructs that extend the AWS L2 CDK constructs and implement our default behavior. This is like really, really valuable for our team, and we've had like great success doing it to the point where we've rolled it out like across all of our projects. And as we've onboarded more teams into the area, it's really been expanded on and improved. So in this example, we have node env app name and app version that's getting set, and it's been read in from an environment variable, but we would read it in from our pipeline, and it would get defaulted in all of our applications. Was a real win, reduced the amount of like change that we were making across all of our apps. So the next one, the next topic is that is one that's dear to our heart. When we were building out this product, we went back and forward so many times on this topic that it became a meme in our team every time a problem came up. So API gateway, obviously the key component in all our serverless product for creating Lambdas. And it's kind of your entryway, how your consumers are interacting with you. We wanted to kind of make the developer experience good, because coming from a long-standing company, we have a lot of non-serverless developers, and we want them to embrace serverless, make it easier, make it easy. So I'm going to talk about a few approaches here, talk about like what I think the advantages and disadvantages are. And like at the end, if you want to come and find me and tell me that I'm doing it wrong, I'd love to hear it. So I like to call this approach the top-down API gateway. So this is actually AWS recommended approach, where in your API gateway stack, you will register your Lambda functions with the gateway. In my opinion, this kind of results in a large amount of change to the API gateway, and it can result in difficulties if you need to delete your Lambda. So we have this, and if you're developing a new service and you need to rename your Lambda function and you can't do that, or there's some CloudFormation property that can't be replaced, you need to blow the whole stack away, this will result in permission denied errors. The only way we found this, the fix we got around this, was to completely remove the Lambda from the API gateway, deploy the code, and then re-add it. It takes a long time. So next approach was bottom up. So the inverse of the last approach, obviously, which is where we would have the REST API ID and resource ID exported from the API gateway. These are the two resources that you need to register a Lambda function with your API gateway. They're just generated by AWS. They're unique for each environment. They're unique globally. They were exported to CFN exports, or CloudFormation exports, and they were read in by the Lambdas at deploy time and used to register with the gateway. The issue with this was it created a hard dependency between your Lambda function and the gateway. So you couldn't delete the gateway, if that makes sense. And that was proved problematic for our team. We had to make a change in the gateway, and we wanted to be able to easily blow it away like any of our compute stacks. So we arrived at this solution. So the bottom up with SSM Parameter Store. SSM Parameter Store is AWS Systems Manager, and it, similar to CFN exports, allows us to export values and retrieve them at deploy time. You can kind of specify a path to the value. It's pretty flexible. There is other uses for Parameter Store. That's just what we used it for. So again, similar approach. But the difference is this time it removes that hard dependency. So I could delete the API gateway here and then redeploy it. It would create a new REST API ID and resource ID that would be imported available to SSM Parameter Store. And all I would have to do is redeploy all of my Lambda projects to have them re-register with the new API gateway. Full flexibility, fantastic developer experience, no complaints. The only issue is, because you're doing this bottom-up registration with API gateway, you're effectively creating stack drift, which is kind of an anti-pattern, but we have never had an issue with it. We ran with this in production for several months, but we ended up changing back to the first approach, but we're in a more stable state now, so we don't have to worry about it. Okay, data management. I'm just going to grab a drink. I'm very thirsty. Okay, so data management. We wanted to build serverless applications. And like I said before, some of the developers in the team were coming from a non-serverless background. So before we went to production, we were actually able to retire all of our document DB databases in favor of DynamoDB tables. When we were first going to prod, we do incremental rollouts, which serverless is perfect for because it's going to scale for what we need. This is a very brief comparison of the differences between DocumentDB and DynamoDB. It's not all the benefits. They're both NoSQL databases. One of them, you have to select an instance size. One of them is serverless and scales. One of them has a 16 megabyte max document size, and one is 400 kilobytes. Fortunately, we were able to get away with using DynamoDB for our use case. We do still use some DocumentDBs for our GraphQL apps, which I believe have GraphQL issues a large amount of read requests, which can be detrimental to the performance of DynamoDB. So let's look at a worked example of how we presented the case to switch to DynamoDB and how we presented that to the business, that this is a good way to go forward before we get into production and this becomes a lot harder. You've got a DocumentDB database in USD1. You read and write 20 million IOs per month, and you store 50 gigabyte of data. Before you do anything, your database cost is $442 a month. Your IO and storage cost is $9, making a total cost of $413.42. Now, that's the smallest size that you can run. You have to pick the size. That's with 2 instances, which is what you would, the minimum for production, you might need 3, depending on your company. If we take those same statistics for DynamoDB, the total cost is $38.75. That's a no-brainer for us in this situation. And it's just kind of a comparison. Like you kind of need to bring, we find we need to bring these numbers to our product owners, to the business, to say, we can spend a few days and change this database. And in the long run, we'll save the company money. So I talked about costs. I talked about a bit the positives and benefits. We use DynamoDB in production. How would I recommend that you do it? So global tables. We only recently adopted this, but we want to have a data disaster recovery region in USD2. We need to replicate our data across. So we were able to enable DynamoDB global tables and have our data automatically replicated across regions. We also would advise setting a removal policy on your document or your DynamoDB databases to retain. So I think the default removal policy on a database is destroy. So if your stack was to get deleted, or if you're running that monolithic stack that we looked at a couple of slides back, and somebody needs to delete their compute and they accidentally blew the prod DB away when they're at it, you're going to want that on. Also, enable point-in-time recovery. This is a feature of DynamoDB that allows backups for 35 days to any point in time. I would also recommend identifying and setting up a time to live, ideally before you go to production, so that all of your records are not living forever. You don't want to keep people's data forever. You don't need to pay for that storage forever. It's really simple. You just specify a field and you write the timestamp to the database, and AWS handles the rest. So next, on the performance, we're going to take a look at some ways that we've improved the performance of our applications and kind of the results of that. So how can we tweak our serverless functions? The main lever that we have for a Lambda function is memory and now architecture, of course. You have the x86 processors and the Graviton 2 processors. Graviton 2 processors are touted to be 30% more energy efficient, cost less, and we find them to be generally better, to the point where we've defaulted all of our architectures to the Graviton 2. You can choose a memory value between 128 megabyte and 10 gigabyte, or 10 gigabyte. And the CPU allocation scales linearly with the memory allocation. I think up to 1.7, if you have more than 1.7 gigabyte of memory assigned to a Lambda function, it will have essentially one virtual CPU unit. So I know I have an unlabeled table in the top corner. I'm sorry about that. So this is a benchmark of a Lambda function ran for 1,000 invocations that calculates prime numbers. So I want to show you how by increasing the memory, you're getting a 10-fold increase in performance. 128 megabyte Lambda function, 11.7 seconds. 1.5 gigabyte Lambda function, 1.4 seconds. I think it's 1,000th of a cent different in the cost for a 10-fold improvement in performance. We've had really good success with this. We have a lot of kind of network heavy calls, a lot of orchestration, and by increasing the memory, we were able to get great performance improvements. So another quick call out, the Lambda Power Tuner. So Lambda Power Tuner is an open source tool that can be used to benchmark your Lambda functions. It works by creating different versions of your Lambda functions with different memory values and just calls them with the payload that you provide it with. It does have a few limitations that unfortunately really hampered my efforts to use it, including crippling anything that is non-serverless and downstream. They won't be too happy about that. And it also doesn't deal well with data that the caching. So if you're caching stuff and you have to send in the same payload for every invocation. So if you send it through once, that's grand. You might get a full view, but any of the other invocations that the Power Tuner is performing are just going to get a cached hit, or they might not work. So again, same thing with DynamoDB. I want to talk about our quick wins, and then I'm going to give you a real world example, and then that's me. So connection reuse. So this reduces TCP connection overheads. So if your Lambda is calling out the KMS to the decrypt environment variable, if it's calling out the read or write from a DynamoDB table, it's making connections to the AWS SDK. In the SDK v2, which is the current version, you have to pass a environment variable to enable this. And we were able to see massive performance improvements with this. In v3 of the SDK, which is soon to become the bundled version, this is going to be on by default. I still think that it's worth calling it out because engineers should have an understanding of how this thing works. Provision concurrency, another great win. And I know you're thinking, if you're running your Lambda with provision concurrency, would you not just put in the Fargate? And I think it's still a valid use case and for scalability and for even your non-production environments. So it keeps your Lambda functions warm and always ready to service requests. We, again, had great success with this. The cost for this is about $10 a month for a 1 gigabyte Lambda function. So it's a pretty good win. Keep your bundle size small. So come across Lambda functions every day that have the AWS SDK bundled up with the function. It should be a dev dependency. I use Node.js primarily, so I use ESBuild for tree shaking and excluding these. You also want to minify your code and make sure you're not bundling up your test directory, which I have seen. So, and caching outside the handler. So you can use global variables to reuse variables across invocations. So you can do work outside of your Lambda handler. More recently, with the addition of top level awaits in JavaScript, we've actually been able to leverage this to pre-fetch dependent API data that actually doesn't need to be done inside of the handler. We can pre-fetch that and use provision concurrency that data is available as soon as a call comes in. So, and results. So I give you all the quick hits. Now here's for a real result. My team inherited a project recently and we had a call with the customer. This is too slow. No problem. Take a look at it. It wasn't using our CDK constructs that had all these nice defaults in it. We hadn't gotten around to converting it yet. I was able to go back and retrofit it pretty quickly, and the results are pretty calm. The P99 latency before we applied these changes was 2.9 seconds. This is a Lambda function that all it does is calls the DynamoDB table and returns the record. it's not doing anything magic. It doesn't call anything else. And we were able to take that down to 282 milliseconds. That's a 90% reduction in time. And that was a blocking transaction for our customer experience. So real world value, these lessons are hopefully useful and definitely applicable and really helped my team. So that's pretty much it all for me. And I just want to say, like, my big takeaways from this talk are that, like, my team has come a long way. We've made mistakes, we've experimented, we've made great progress. They're here tonight, and I'm really glad they are able to be here tonight. So, you know, focus on your performance, nail down your consistency, check your costs. How can you reduce it? How can you drive it down? That's pretty much me. Thanks for listening. Hopefully it was useful. If there's any questions.